as well. So we're starting with a recording. I'll share that. I normally share that on YouTube, and I will then add a link to the WhatsApp group as well to that recording. I'll also share the presentation in the WhatsApp group as well. It will also be on the My UNISA portals. So if you need to get that through the My UNISA portals as well. But once again, please let me know if there's better times for this, that we can go through the work. Okay, so today looking at the first two, numbers and variables, and then basic operations. So nearly again, and you would see that in your assignments as well, is that they can ask you a bit of definitions. Mostly they ask you to work out problems and work, but it can be that they also ask you definition kind of questions. So what I might in some of the examples just show you some of the definitions. Hi, Ndima.
Hi, I was just checking. I'll leave
Yes.
just now.
Okay, thanks,
All right.
Ndima. Cool. So what we're looking at under the numbers and variables is a few things. So we will need to identify the different kinds of numbers. On that, they might ask you a few things. We will look at draw a timeline or number line. Again, just important, you guys don't need to, they can't really ask you in the assignments or in the exam to draw a timeline. It is multiple choice, so they can rather ask you to say which one of these timelines are correct when you look at a certain question, but they won't ask you to draw anything because that will not be possible. We're going to look at how to round off numbers. So if it is to one decimal, how to round it off, 2, 3, 4, for some of those. Then we're going to look at how to explain what a variable is, how you're gonna use it, and then nearly how you're gonna write down some simple equations by using the variable. So if we have a variable x and y, and if I give you a bit of information around that, how to write it down in a simple expression. Okay, so what I've done, and that's also why I'm going to share the slides afterwards, and then from the next time I'll send you the slides before we have the session so that you can all have it at hand, have it, make a copy of it or print it if you can, and you can make the notes as we go along. But from the next session, you will have the slides available. So basically what I just did is drawn a summary of what numbers are. So we can look at a set of natural numbers, which is normally just anything above 0, and that you can count. So 1, 2, 3, 4, anything like that is your natural numbers. Then the next one is whole numbers. So the only difference between that is that you include 0 in that number set. So whole numbers 0, 1, 2, 3, 4, and upwards. So that is natural, whole, and then we get integers. So integers again is looking nearly at whole numbers, but it can be positive or negative. So you can have negative integers, -1 going down, can have positive integers from 1 upwards, and then 0 is also an integer, not negative, not positive, it's just an integer. So that is nearly looking at that set. And then we also have something that's called rational numbers and irrational numbers. So rational numbers is, again, things that you can easily identify, easily see. So something like a fraction is a rational number. If it's a number that is 2 or 3 decimals, it doesn't matter, but you can actually see that the decimal is not going on. It is a specific length of decimals. That is a rational number. An irrational number is, and if you put it in your calculator and you don't round the number off, you will see it just goes on. So the square of 2 will be something like 1 point, and the rest just goes on. The same if you look at 5 squares. So it's mostly things to do with a square number or a cubic number, and it just goes on. So unless you round it off, it stays an irrational number. And then I added just, sometimes they ask it, sometimes you don't have it in the study guides, is complex numbers. And complex numbers is normally a combination of 2 number sets. So normally it will have a link to something that has a variable in it. So in this instance, the variable is I, but it could have been any other alphabetic sign that we use. And it will be linked to one of the real numbers. So it doesn't always need to be linked to an irrational number. It can be 7 plus 2i. That is a complex number. 3 minus 4i. So it doesn't need to be always the weird irrational numbers that's linked to it. It can also be a simple natural number, a whole number, or any of the other number sets. So this is your number set. What they can do in your assignments and in the exam is give you a list of numbers, and they ask you which one is rational, which one is irrational, and things like that. So I quickly went into a few of these, and that we need to identify. So this might be something that they can ask you in the test or in the assignments and in the exam. The only difference is that you will get options. So you will get A to D or A to E options. So it might rather be that they say they give you a few numbers, and they ask and they say which one is irrational, and then you need to pick. Might be rather something like that instead of saying complete something. Um, but let's look at the options. So we've seen now with this, and again, why I will share these is because you can use this as notes as well when you do the assignments and the exam. Again, you're doing it online, so you have some of these tools available. So we can look at the first one and say, okay, but sure, that's a whole number, but that can also be an integer. So there's a few things that this first one could be. So if you look at it, it's a real number, it's a whole number, it's also a positive integer. So any one of those will be correct. So again, with a lot of these, there might be two or three answers. Okay, when we get to the negative one is basically just it can be a real number. It is also a negative decimal that we haven't covered in any of those. So I would nearly stick with the last one that it is a real number. And then the last one, the fraction, again, if we look at what it could have been, it is rational or real numbers. So we could have said for the fraction, it's a real number, which is correct. If we needed to say more, it is a rational number as well. So again, when you complete this or when you get something like this in the assignments or exam, they need to be able to tell you, okay, well, all of these might be real numbers. Which type of real number is it? So that you then can go and add it and say it's rational. Otherwise, real number is perfect. Okay, so then the second topic. So after we've done the numbers, the second topic is rounding off. So how and the rules with rounding off. So if we have, and let's make it 46741. Okay, so they will tell us to round off to, let's say, 2 decimals. Then we look at the third decimal. And that third decimal will then tell us if we round it up or if it stays the same. If that third decimal is 5 or higher, we round the previous number up. If it is 4 or lower, we keep it the same. So if the number was 3,47 or 467, round it up, it will become 3,47. If we needed to look at 3 decimals, so we look at 3,467, and we need to round it to 3 decimals. We look at the fourth decimal. In this instance, it was 4, so it is 4 or below. We'll keep the same. If we needed to round to 3 decimals, we would have kept it the same, 3,467. Okay, so again, I might add something like this as a definition kind of question, but most likely not, but they can. So that's why I just added it for you, so that if there is something like this in an exam or test, then at least, or sorry, assignment, then at least you have a definition component with that. Okay, so then some examples that we're looking at the same number every time, 34,9974321. So the first one, they ask us to round it off to 6 decimals. So when we round off to 6 decimals, we look at the 7th decimal and decide what to do. So 1, 2, 3, 4, 6, 7. Okay, so we have 34.99743. We look at, wait, 1, 2, 3, 4, 5, 6, 7, sorry. I have missed that one. So we look at the 1, and we decide what we need to do. Do we round up? Do we keep it the same? 1 is below 5 or 4 and below, so we'll keep the decimal of the 6 decimal exactly the same as it is. So it will become 997432. Okay, when we need to round off to 4 decimals, we look at what the 5th decimal is and then decide. So 1, 2, 3, 4, 5. So the 5th one is still below 5. So again, we keep it as is. So it will be 0.9974. And then if we round off to 2 decimals, we need to look at what the 3rd decimal is. So the 3rd decimal tells us that we need to round it up. So 9 rounded up gives us 0. So it's actually rounding it up to 10. But that means that we're actually adding 1 to a 34. Okay, so if we needed to round it off to 2, even 3 decimals, it would have been 998. 2 decimals, 35.00. If it was rounded up to 1 decimal, again, it would have rounded the 9 up. So it would have been 35.0. And if there was no decimals, it would have been just 35. So that is how we would round up the decimals, and you can also see the answer set below. So again, what will happen in your assignment is they need to all give you options of how it will look like. Because again, you need to choose between one of the options. Okay, so that is on rounding off, and depending on where it lies after the decimal, how you need to round it off. Okay, then the next set of things that we're going to look at is variables. So in this instance, firstly, we need to see what the definition of variables is. So a variable can be considered as a placeholder in which values can be placed. So that is your definition if you ever need to recall it in an assignment. But basically what that means is if I've got something written as 4x equal to 6, that 4 is a placeholder. And it's a placeholder for me to actually work out what the value of that x will be, so that 4x will be equal to 6. So that is basically what a variable is and what it refers to here as a placeholder. It stands in the place of a number that you will need to work out. Okay, so what they can ask you is, but here is a sentence and you need to write it as if there is a variable in that equation. They can also ask you to, they can give you equation and ask you to work out what the variable is. So they can do it both ways, but most likely it will be that it is nearly in a story sum or something like that, where they or word sum, and you need to work out or write it as a function. Okay, so here they tell us 3 times a number minus 6 is equal to 24. So we assume that the number is x, unless they tell us we need to use a different number. So 3 times a number minus 6 is equal to 24. So that is basically what they have asked us to write down. It might be now that they ask you to solve that, but in this instance, we only needed to write down what the basic function will look like. We will, in the next study unit, work it out. But if you now needed to work it out, we can basically say, okay, well, 3x, what we do to get rid of a 6 on the one side is we say, okay, plus 6 on both sides, so that minus 6 plus 6 will fall away. But if we do it on the one side, we need to do it on the other side. And then that will lead to the function being 3x is equal to 30, with when x being equal to 10. So that is if we needed to work out what the variable is. So the variable would have been 10 in this instance if we needed to work it out. Okay, so that is a simple question where they ask you to write it down. The next example might be, so again, a word sum, twice a number plus 3 times another number is equal to 120. Okay, so let f be the first number and s the second. So twice a number, so twice f plus 3 times the next number. So 3 times s, that is a s, it's not a 5. So 3 times s is equal to 120. Now, again, that is how we can't, it's not like the first one where we could have now worked out what x was, because we don't know if that is what f or s is. So there's no ways we can work it out with more information. But that is basically how we would write the first function, as you have seen, 3x minus 6, and this one, 2f plus 3s equal to 120. So that is nearly how we can look at it and write your variables. This will lead basically into the next section, where we will look at the basic operations and things like that. So let me quickly just stop here and quickly ask if this if it makes sense, if it is at least helping. I assume this was already done for your nearly assignment. So again, Tamlin, if you can share, or anybody else looking at this video can share with me what your assignment due dates are and what you need to submit for that, or what topics it covers, so that we can just get a bit alignment when we do these sessions. And then also for the guys listening, if you can let me know if there are better times than on a Saturday for these sessions. I'm always worried that you have clashes with other subjects or with lecturers assisting as well in this time slot. And then just again, my WhatsApp number, there's a link in the chat, but also if you want to send me a WhatsApp number on 083-790-8387, and I will add you to the WhatsApp group. Okay, so that was the first session, things that we needed to look at for BNU, so it is numbers and variables. Now we go into a basic operation component. So for basic operations, again, few things that we will look at. Firstly, how to perform basic operations on numbers and variables. So basically what we did in the previous slide. So if we need to solve X or solve for something, that is what we will focus on. What we will then add also is basic powers and roots. So we will look at things that we add, so x to the power of 2 or x to the power of 3 or anything like that, but also square roots. So what is the square root of 9? Or it might also be that we look at cubic roots. So what's the square, or not, what's the cube of 8? So we will look at powers and roots, and then the last one is that we look at how to look at basic operations, and then sometimes we call it BODMAS, or there's a few different abbreviations for that, but we basically want to say, okay, but what's the order of calculations? So you normally will first do you do brackets, you do other operations, you do division, multiplication, adding and subtracting. So we will then go into the basic operations context as well. Okay, so only a few slides left. So this is actually a short session today, but next week we'll continue, or if we need to be in a week, we will also continue, might continue in the week. Okay, so I decided let's pull the operations component first, because to do the others we need to do basic operations first. So the first one is just addition and subtracting. So we can just in this one go from left to right and work it out. So we can just say, okay, well, 35 plus 42, so that gives you 77. If we subtract 16 from that, we get 61. And then if we subtract 8 from that, we get 53. Okay, so that could have been one way of doing it. Another way could have been to say, well, we add those two, it gives us 77. We add those two, that gives us 24, but it's minus 24. So 77 minus 24 would have given us the 53 as well. But basic for operations, we start from the one side, we move through, because it's addition and subtraction. There's nothing that we need to do the first before the second. We just can work from left to right. Okay, so that is your addition and subtracting. Then The next one is looking at multiplication and division. So in this instance, we do multiplication first. Here is only multiplication. So this would have been nearly straightforward. 35 times 2, which is 70, and then 70 times 3, and my answer would have been 210. So you could have done also to say, okay, but what is 3 times 2? That is 6, and 35 times 6 is also 210. So you could have done it the other way around as well, to say, well, 2 times 3 is 6, times 35, that is also 210. Okay, so with multiplication, it doesn't really matter which one you do first. It will give you the same answer. Okay, now the next one is where there is a division. Sorry, not the division in between the multiplications. So again, let me show you a few options. So we could have gone and say, okay, what is 7 times 3? 70 times 3, that is 210. 210 divided by 6 is equal to 35. And then 35 times 20 is equal to 700. So that is one way of doing it. We could have said, okay, what is 3 divided by 6? That is a half. So we could have said 70 times a half, which is again 35. And that times 20 gives us again the 700. We could have said, so that is nearly, I want to say, what, probably not that, because we need to work from this side. Okay, so that is nearly 2 ways that we again could have worked it out. We get exactly the same answer. So addition, subtraction can work from the one way. If it's only multiplication, you can work from any side. If it was only addition, again, you can work from any side. When it is a combination of multiplication and division, easiest to work from left to right again. But if you first wanted to do the division, it would not have mattered in your final answer. Okay, so that's basic operations. The one thing that I just want to add here, so I don't think I showed it somewhere else, so is that if you, and let's just put it in here. So it could have been that you also get a question like this. So let's just, so when you do the brackets first, so 3 plus 5 is 8, and then you multiply it by 70. Okay, so that is important. Nearly always do brackets first. If there wasn't brackets, and it was 70 times 3 plus 5, we will do multiplication first. So then it would have been 210 plus 5, where that one would have been 70 times 8 would have given us 560. This one will give us 215. So very important to follow the rules of first brackets, then only multiplication. Okay. If there is multiplication and addition, when you first do multiplication and last the addition component. Okay, so that's basic operations on numbers. Then the next one is when we add variables to it. So basic operations on variables is we've just added a variable to it. Here is some of the definition and the theory behind it. I thought again I would just show it. So if they ask you somewhere in an assignment or in the exam, what is the constant, what is the variable, what is the coefficient, then at least you can see it here. Also, what is the operator in this environment? So if needed, and they ask you a bit on the theory of that. But when we do the basic operations and just look at the question, again, what we will do and what's important now with the variables is that we need to group the variables that are similar together. And then you will see that we will do the C's and D's separate. So we'll first do the C's. So 6 plus 7C is 13C, minus 3C is 10C. Okay, so we'll do all the C components first, and then we will do the D components. So the D components then is minus 12, minus 23, and plus 13. So if we look at that, plus 13 minus 23 is minus 10, minus 10 minus 12 is minus 24. So that would have been minus 24D. And that would have then be how you solved or simplified the basic operation with a variable. So that is on your addition and subtraction component, but we will also work with it as multiplication. So what we need to do multiplication, we do that one first again. So 5a to the power of 2 times 4b. We will just add the 4b. Then what will happen is, so we've got that 4b. So we will divide that by 3a. So, and then we multiply it by 6b. So you can also write it in this format, and then we can say, okay, but let's simplify. There's a to the power of 1 goes into there once, goes into there, so the 1 is left. 3 goes into 3 once, 3 goes into 6 twice. So then our answer that we're sitting with is 5 times 4, which is 20, times 2 is 40. 40, there's only one A, but there are two B's. And everything at the bottom has disappeared, so we're dividing by 1. So our final answer will be 40AB squared. Okay, so that would have been the way how we solve that. If I brought in, let's say, brackets there, then in this instance, it will be exactly the same. That would just now have changed to 4b over 3a, which you will see would have happened in any case there. So it would not have changed the operations. Ooh, okay. I don't know what what happened now with that screen. Let me just check if I can get it back. Cool. I will just again quickly share. Okay, there we are back. Hoping you can still see it. So if we had brackets there, because it's multiplication and division, it would not have mattered. Only when we bring in addition and subtracting and put brackets then on around things, then it will change what we were working with. Okay, so that is basic operations with variables on addition, subtracting, multiplication, and division. So the next one that we will look at is powers, and also included here is some of the laws of exponents. So when we need to work out certain of the answers or questions, you can see that there's certain rules that we need to follow. So if it is the same, your base that you're working with, if that is the same, you can see that we can just add or subtract. So in this instance, if I look at that rule of number 1 and that rule of number, well, we don't have that, we just have the negative, so I just would have used that as positive and negative. So the A3 and A1 we can write as this, and then the B2 plus B4 we would have written as that, and then your answer would have been A to the power of 4, B to the power of 6. You could have written that as A. Okay, I am really struggling with my screen today. So you could have written that A3 minus 1 as A3 divided by A1, like we have there in rule 5. But what then would have happened is you could have said, okay, but there's 1A, there's 3A there, so what is left is 2, which then would have given you A2. That is exactly the same as in that final answer that we had in any case. Okay, so again, using the laws, we could have used that one and we could have used that one and gotten the same answer. Then if I look at this example, in brackets 5a to the power of 2, 2b, and then everything to the power of 3, I will use this law of number 2. So which tells me I basically take whatever is within the bracket and I need to multiply. So what is important is, remember, this also is a base, so we need to use the exponent for that as well. So 5 to the power of 3, a 2 times 3 will give you 6. Remember, 2 times 3, then 2 to the power of 3, and b to the power of 3. And then, again, we can simplify the 5 to the power of 3, the 2 to the power of 3 if needed, but that is how we would have calculated it. Then just other laws that I don't think it's on here, but just not laws, but what makes it also very, very easier to work with is, so if we have 1 over a to the power of m, that is what we had there, we could have said, or that is similar to a minus m. So that is just a nice one to remember, because if one needs to work with it, you can simplify it. Okay, so that is nearly powers or exponents. Where we have positive ones is when it's just a positive, negative will be a negative number. So positive is for positive 2, negative is negative 2. So that is basically the two types of exponents that we can work with, and we can just use it on a set of variables as well. Okay, so that is powers. Then we sit with roots. Is, I think it's nearly the next one and might be the last one. So roots is basically looking at, there's different types of roots. What you most likely will only look at is the square root, but it might be that in an instance they ask you the cubic root as well. But that is how far it will go. But the cubic root is, then it will be something that, like in this instance, 2 to the power of 3 will give you 8. So if you add the cubic root of that, your final answer will just be equal to 2. Okay, so that is the furthest I would go with roots, is to do cubic, but most likely it is just square roots. So what they will do with square roots nearly is, they will give you underneath that root, they would give you a number that you can simplify. So if we look at 144, and if we go back to nearly your timetables, 12 to the power of 2 would have been 144. So if we take the square root of 12 to the power of 2, that answer would have been 12. Then if we look at 64, again, go back to your tables, 8 times 8 would have given you 64. So we would have said, well, 12 minus 8 is your answer of 4. The one thing that you should not do, and I think that is just important, you can't say 144 minus 64, that gives me, what is that, 80, and now you work out the square root of that. That is not, that you can't do. So that is not how you do it. you need to first work out the square root of a 1, the square root of the other one, and subtract the 2. Again, you are allowed to use your calculator. So if you do with your calculator, you would in any case see that the square root of 144 is 12. Okay, so that is looking at your roots. Within the roots, you would also see that you can sometimes have variables. So x to the power of 2. So if we take the square root of that, it becomes 2. And I've just listed a few here that might be shortcuts for you to look at. Okay, so that nearly covers, if I look at what we did now in this, we looked at operations, we looked at powers, we looked at roots, and then the last one is just again to quickly relook the order. So the only thing that I included for you is nearly a simple method of identifying the order of operations. So the first thing, always brackets. Then if there is something of order. So if we look at this question here, what we first would have done is the bracket. So 3 minus 6 is minus 3. That to the power of 2, and then in the other bracket, 5 plus 2 is 7. So we've done the 2 brackets. Then we would do, if there's any order, here there is. So minus 3 to the power of 2 is 9. So what is 9 minus 7? So we've done order. There's no division or multiplication, no adding, but there is subtracting. So 9 minus 7 gives us 2. Okay, and important about the order of things and what was needed with the brackets. Okay, but again, I've included this so that you will be able to just use it later on in other examples as well. So again, keep it close by if you need to do work for your assignment and your exam. And that was nearly a quick run through of the first two chapters for numbers and variables and basic operations on numbers and variables. So just a quick check-in, Tamlin, did that help at all? Does it make a bit more sense? What is your feedback on this? I'll stop the recording so that you don't need to worry about